Can you hear me, Tim?
I can hear you, yeah.
Great. Okay. Well, a strange thing is this is my iPad. My Mac is still not booting up. This is really strange. And that's my only computer. Well, I have the iMac inside, but I don't want to go there. Okay. Well, you know what? It doesn't matter. I can do the class over the the iPad channel. Well, maybe the Mac will complete the boot up process in a little while, and I can switch to it. So it's really strange. Why is it? I thought it was a device driver issue, but it's not even. Yeah, maybe. What was there? A system update last night? I forget. Anyway, this Mac is getting really old. Maybe it's just the age. Okay. All right. Well, we can wait for. Are you the only one? Are there other people in class? How can I see the rest of you guys? Hang on. Oh, you are. Okay. Yeah, I had to hit the, the iPad interface is different. I had to hit the plus button and get. So I only see 3 of you now. Is that right? Or there's only 3 of you? Okay. All right. Okay. That's okay. We, it's being recorded, and people who are not here can watch the video. Although I think, starting next quarter, maybe I'll just stop recording these things, and the classes are only available to those who attend. I think that might make more sense. Anyway, so what did we do last class? Yeah, we did pointers, nodes and pointers, right? So yeah, I was thinking of something interesting to do today, which is not straightforward, but it's still interesting. Okay, that we can do with linked data structures. I don't know if you would have encountered this problem elsewhere. So here it is. What we can try and do is create a ring. Okay, ring meaning beads that are connected to each other, and the last bead connects to the first bead. Yeah, so it's a ring. So when you start at a node and go to the next node and the next node, eventually some next node is going to be you. So you're going to be around. So I think we can do that today. And I was thinking, actually, this morning in the shower, I was thinking, how can I make it more interesting, right? As I maybe inject a bit more fun in it. And I thought, well, you know what, we could turn this into a roulette game, right? Roulette, because or a wheel of fortune. So we can have a ring, and then we can use our standard, random and sleep methods that we're already familiar with. And then when you start, well, it'll tell you all the numbers in the ring, right? And then you can take a bet, you can place bets, and then it's going to start the ball, okay, at one of the beats, and it's going to go round and round in a circle and get slower and slower. And why is it? There's no animation, okay? Well, let's not do animation and all. It's internally in memory. It's going to start at a node, okay, go to the next node, print it, next node, print it, next node, print it, and so on, and it keeps doing that, and it gets slower and slower. Well, yeah, maybe there's a very slight bit of animation, not real animation, but printing, right? And then when it stops, it says, well, the winning number is 47, 22, or something like that, right? Actually, I've never been to Vegas. What are the numbers like on an actual roulette wheel? Well, maybe you can Google and find out. Is it 1 to 100, or is it? I don't know. Maybe someone can Google and find out what are the numbers. Well, we don't care really, right? I think we can use numbers 1 to 100, and maybe 1 to 100 and maybe 50 nodes, right? 50 nodes in a ring, okay? Each one has a random number from 1 to 100. And then when the game starts, we all take turns and in putting our money on various numbers. Okay, so Kate says 23, and Jaden says 14. Tim says 75, and so on. Okay, and then we hit enter. And then we're going to see the wheel not spin, but virtually spin, in a sense. It'll say, the pointer is pointing to 100, bam, 72, 81, 4, 7, 6, 3, 1, 7, and so on and so forth. And it's going to, the time between these is going to get slower and slower, which we can address with RAND and sleep. Okay, eventually it's going to get longer than a second. And at that point you can say, okay, the wheel has come to a stop. Okay, and that's the winning number. How about that? Does that sound like a cool game? Yeah, it is totally implementable by you guys without my involvement. Okay, and in fact, I think this is a good way to do it. On Tuesday, I can be involved in the coding, meaning that I'll be coding with you as much as possible. But let's try and make Thursday classes. Well, you know what? It sounds like a great time to propose this, because there's only one more week to go, and next week is week 11. But maybe I'll do this next quarter, or some of the quarters after. Yeah, I think Thursday should largely be you guys coding, and then I'm just watching, and I can help where necessary. But this will be quite useful and easy. And obviously, my Mac is still not booted up, so I can't code. Well, the screen is flashing. Hey, wow, it actually did come up. Okay, well, it took a long time. You know how quickly Macs boot up, right? Usually it's like 10 seconds or something. Yes, most of the modern machines are 10 seconds boot up. This one took like I don't know, how long is it now? What time is it? 8:18. So it actually took 15 minutes to boot up. Wow. Okay. So there must have been some really serious issue, and it had to download lots of patches, maybe. Well, I hope I got the sound back. Let's see. But anyway, it doesn't matter. So while it's doing that, why doesn't someone, one of you, take the screen? Okay, it doesn't matter who, right? All of you are familiar, and all of you I know are comfortable with code as well as driving on screen. So it doesn't matter to me. I don't want to force any of you to do it. But one of you should just basically take the screen, share, VS Code or Xcode or one of those things, and we can start coding inside of it, right? And I think, yeah, we don't even need to go to a terminal this time. We should be able to run it inside of the IDE itself, and I think it'll work. Okay, so I in my mind it is playing out quite nicely. Okay, so I think I'm seeing the result of the app, the thing that we're going to implement turn out to be quite nice in my mind. So wow, I can the iPad screen is quite crisp with these glasses. Okay. All right, Jaden, thank you very much. Are you guys ready? Do you want to start coding, or you want to just talk? Jaden, don't unshare your screen, okay? Just leave it there so that we know that you're going to be coding. Yeah. Okay. Now, how about what time is it now? I just saw the same 8:18. What is it? My time is completely gone from the screen now. I think it's 8:20 now. Oh, I got my phone here. Yeah, 8:20 exactly, on the dot. Okay, so how about 5 minutes? Okay, 5 minutes. You guys want to talk and chat, or ask me questions of about any of the topics that we've done before. That's all fine. So let me know, okay? Yeah, well, it's why? Okay, my email, but I need to go to my Zoom window. Yeah, so I'm just, I'm just waiting. You guys can chat or ask me questions, and I can answer your questions while I'm fighting with Zoom. So it's not a big deal. It's horrendously slow. Just email. Maybe it's just still booting up, background boot up process. Okay. Oh yeah, I got to do my summer syllabus today. Okay. Zoom. Okay. Let me see if I can join. Oh, let me see if I can. Oh wow, speaker works. Okay. All right. You know what? I'm not going to bother connecting from my Mac. We'll just run it from my iPad for today. All right. So not a big deal, because I'm not going to be typing. So you guys are typing, right? And I can code through my eyes with your help. So thank you so much for that. Yeah, it's kind of cool, right? So modern technology makes all these possible, right? You don't have to do a lot of things, you don't have to do some really great groundbreaking things. You're sitting in a chair. But Stephen Hawking is sitting in his chair, and he says, well, that black hole is probably spinning the wrong way. Right? Okay, and he does that through technology. So your mind can be completely free and occupying the entire universe while you're sitting in your tiny home, and that's so cool. The power of technology. Okay, so anyway, so this is what we want to do. You guys want to talk? I'm not going to start my Mac, okay? So I'll just reduce the brightness too, so it's not glaring in my eyes. Okay. And I'm glad, I'm glad that, many times Mac issues, I have problems, but rebooting it, they tend to download some patch that fixes the issues. So most of the time this has happened, that not this bad, but it's self-recovered, which I've had less luck with both Android devices and Windows. I've had less luck with self-repairing like this. Whereas with Max, I have had great success so far. Anyway. All right. So do you guys want to talk? In fact, I can just turn it around for 5 minutes. I don't have to be in your face. You can just have a free form conversation. You know, technically, this is the last penultimate week. You only have one more week. And then you have a week break. And then I'm going to see most of you again in CS2B, which is pretty cool. And although CS2B is, you know, online, purely online, I would still like to have weekly meetings, at least one meeting a week. Well, 6 weeks. We'll try to make it 2, but we'll start with 1 meeting a week. Are you guys okay with this? You know, Tim and Kate are the only ones who are enrolled. We can have 1 meeting a week. And we don't have to make these meetings, you know, hard coding every single time like we do in 2A. We can just have concept discussions. And if necessary, we can pick a small project that one of you can implement, just like we're doing now with 2B concepts. And we can, I can just do exactly the same thing. We'll just continue the whole story, right? In fact, we can do this all the way until the end of CS2C. So we can have these meetings and we pick a project, you code, I can watch, and I can, you know, nudge and tweak here and there. And in the end, we come up with some really cool stuff, right? We're really cool stuff that, you know, I have a great deal of fun just running your programs and looking at what they do and all. So that's kind of cool. All right. So talk for about 5 minutes. Okay. We'll start coding at 8:30. And what time? Yeah, 8:30. And hopefully we'll have a few more people that join by then. But otherwise, we'll just start coding because they can watch this video and learn. Okay. And you're all pretty much on the, you know, I think similar quests too, close to 9, right? 8 or close to wrapping up 8, or started working on 9 already, and you have a whole week 11 to finish 9. And I think that is perfect because you will actually need up to a week to finish 9, and then you're set for the finals. You're set for the final exam. And the final also, you know, it's just going to be like the midterm. If you do an absolutely horrible job, okay, in the final, and you say, oh my gosh, I totally tanked the final. Only the people who have been regular in class or have been sending me email and saying, well, I can't make class because of this reason, it's valid reasons and all, I'm more than happy to give you a second crack at the final exam. Well, Thursday, right? Yeah, I can give you a second crack on the Friday. Okay, I can give you a second crack on the Friday for the guys who are regularly attending class. So you don't have to feel panicked about this at all. And just take it easy in stride. All of the material we've covered in the second half, that's going to be the major emphasis in the final exam. And I like the way that we have progressed in this class, actually doing stuff, okay, doing stuff all the way. Because I know that there are sections where you don't really have to do stuff. You can just learn the theory of it and get through, but you guys are all coding, and that is what every CS instructor wants to see. Students coding, not learning without coding. All right, so yeah, go ahead, chat. And in fact, you guys are not talking when I'm in your face, okay? So I'm just going to be here behind the screen, but you guys chat, any other questions. What you can do is actually ask each other what topics you guys think we should focus on today, right? Other than linked lists, or you know, in addition to linked lists, maybe if you want to do a particular kind of looping or some kind of thing inside of a loop, we can work that into our linked list problem. So we can do all those things. So this is a chance for you, about 5 minutes, to talk to each other and find out if there are interesting concepts that you're still not 100% on that you'd like to be worked into today's coding session, and we'll absolutely try our best to do that. Okay. So 5 minutes, and I'm just going to turn around the laptop, and I'll be back in 5 minutes. I'm just going to be here. Okay. And call me anytime you guys have a question. Call me. If you have a doubt, you can call me also. But otherwise, just keep talking, okay? And find out what you want to talk about, do today.
How's everyone's progress doing? Are there any coding aspects you're still having a bit trouble understanding? Or?
Yeah, have you guys all finished Quest 8 already?
I'm still working on it. There's a problem I've been having where it keeps exceeding over the limit of 10 printed results.
Oh, wow. I think you're still a little further than me. I kind of got sick at the beginning of this week, and I had to take some time off of work. I was using that on Quest 8, and I realized, like, after the fact, like, I needed more time on it than I thought. still trying to get mine to actually, like, when I get submitted, to actually not have errors right now.
So would a good way for it to stop exactly from printing to 10 would be using less than or equal to, or would it be more better to use an equal to 10 to make it stop printing?
You're talking about like in a for loop, or?
Yeah, I believe that's what I'm using.
I don't know if I would have an answer for which one's better, I guess. A lot of times when I have troubles like that, I'll like take a little snippet of code and just bring it over to an online GDB session and just like test out the technicalities of it until I get it to work the way I want it. I guess in most things, like going from like 0, if it's counting from 0 to 9, you're trying to get 10 elements. I'll put it as like until it's like greater than 9 or greater than 10, as long as it's less than 10. But then there's some things where you need to actually, I don't know. Every program's different.
Yeah, and it's also weird that we're not actually submitting a main body this time around, we're submitting a header.
Okay, are you guys good? It's 8:30 now. Are you guys good? We can do you guys want to talk? Start coding? Yes.
Sure.
Okay. Any particular concepts that you wanted to use today? I think I heard you talking about looping and when to stop your looping and so on. So we can try and work that into the Russian roulette, not Russian roulette, the roulette problem, that the game that we're going to code today. Is that okay, Jaden?
Yeah, that's fine.
Okay. All right. So
yeah, I also wanted to just say something while you were talking. I was listening in. It's just that sometimes I tend to get a visual impatience. So I was accidentally looking through my dashboard. I forgot I had my screen still sharing, but I was when that was happening. But I was listening.
I'm sorry, I didn't understand what you're saying. Do you want me to edit the video to remove the first part where
No, that's fine. No, that's fine. It was just my dashboard, so it really wasn't a problem.
All right. Yeah, it let me know if you accidentally showed personal stuff on your screen. As long as it's in the beginning or the end, it's easy for me to cut. Right, I can just cut it out and before I post it on YouTube. Okay. the worst thing that I had to do in the past was some student. This is several quarters ago. They had so many. This is when I learned my lesson to say, make sure you guys are going to be in a private incognito mode, because that student had a Chrome window with their email, and that appeared like 5 or 6 times in the lecture, and then I had to edit. Well, I could just have not published it at all, but I think it was a important lecture, so I had to go in and remove those things. Okay, all right, good. So are we ready to start coding now? Okay, Jaden, so get rid of the main, get rid of the hello world, so we can just have the template, just the hello world part, and insert code here, right? So that return, you can leave the return there because we're going to have the return at the end, right? So we don't need the hello world. Okay, that's the only bit we need. Okay, now let's go above main and put our standard declaration there. This is VS Code. No, this is Xcode. Great. Okay, right? Yeah, enter, and then using namespace standard. Yeah, semicolon, enter. Okay, great. Now let's define our node class. Okay, so say class, enter, and now is one more enter. Yeah, and up. Yeah, thank you. One more up. Great. Class node, and then space brace. Enter, and you don't have to wait for me either, Jaden, because I know you know these things. Okay, and I know that Tim and Kate also know these things, and we don't have, well, I guess, you know, people will want to watch the video later and they could, no, yeah, you can go at your own speed, because if they're just watching the video, they can pause, right? So you don't have to go slow for anyone. So the rest of us in class can follow you, right? Yeah, put a semicolon at the end of the closing brace. Okay, that's our class template. And inside, let's just say everything is public for now. All right, we won't use getters and setters. Do you guys want to use getters and setters? If you want to use getters and setters, we can use getters and setters. Let me know. Otherwise, we'll just do everything public. You want to use getters and setters? Do you want to practice in using getters and setters? Do you know what getters and setters are?
Yeah.
Okay, all right, cool. All right, so don't say public, say private. Okay, cool. All right, so this is how you do getters and setters. And the reason we didn't do it last class, and the reason I de-emphasize it, is because most of the time, the basic getters and setters, the compiler will do it for you. So if you go to VS Code, I don't know if VS Code does it. Certainly Eclipse used to do it, right? So you can just right-click on a class and say, fill in all the getters and setters, and it'll do it for you automatically. That's what we're going to do, right? We're going to do what the compiler automatically does for us. Okay, so first let's define our variables. There are two private variables are, yeah, okay, so let's make them private and deal with it later. Okay, so int and number, say num, right? Or
just num.
Yeah, num. And then semicolon. And then the next one is going to be node star next. Yay, yes, that's correct. Yeah, no. The star goes on this side.
Oh,
Yeah?
okay.
Well,
Sorry, I remembered it.
Here's an easy way to remember it. Okay, here's an easy way to remember it. And all of you, right? So why does the star go on this side and not that side? Because we're saying it's a node pointer, right? It's a node pointer. And technically, it is possible to say that star node is a type that is a pointer to a node. Yeah, because that's how it reads, right? Star is a pointer, dereference, and node. So star node is a pointer to a node. So we can, you know, the C++ designers could equally have said star node is a type you use for pointers. Yes or no? Right? Yeah, they could. So, but still, the design decision was to say node star, not star node. Why is that? And the reason for that is because it says you are still going to be defining a complete node variable, not a node pointer. It's a node variable. However, that is not your node variable. The contents of that is your node variable. Okay. So in other words, so we say node space star.
Node space star.
Yeah, no node star. Yes, node space star, and then immediately next next. No, yeah, don't put the space there because yeah. The reason I say don't put a space there is because then it looks like a binary multiplication operator. Yeah. So by doing this, most programmers will instantly get the subconscious cue that it's a pointer. Okay, next is better actually than, if you want, yeah, I think conventionally most people use next, even though num and next and next same number of letters, which is aesthetically more pleasing. Yes, but okay, all right, semicolon, enter. Now we're going to define some public methods. Okay, so one more blank line. Okay, and then say public and colon. Yeah, LLIC and colon. All right, enter. Next line. Now we're going to say const, not const, int space get underscore num. Num.
Yeah, I was spelling it out.
Yeah, I know. All right, open parentheses, close parentheses, open, close. And then after that, you're going to say const, const. And then space, open brace. No, brace.
Oh, right, brace.
Yeah. And then this is the body of the, put it all in one line because, it's just going to be one line. Return num. That's it. Just on the same line, you can say return. Oh, yeah, okay, that's fine. You can do it like that. All right. Now do the same thing for next also. Get next. No, it's not int. What is next? Get next return.
Oh, right. It's no. Get next to the node, right?
Yes. So yeah, put the right type in there. That is actually almost like an exam question here, but we'll see.
Node get.
Okay, and you guys can fix it. Okay, yeah, Tim and Kate, if you think that's needs to be fixed, fixed, let him know, right? So what the fix needs to be.
So when saying return, I would have to put in the star and the next, right?
No, return. You just say return next. Return next.
Okay.
Right now, there is a very small bug, and it's a very common bug too, right? So what is the issue? Put a space after the const also, where you have your mouse cursor. Yeah, there you go. Hit space. Yeah, okay. All right. So what is the tiny bug that we need to fix? And it's a very common bug, and you'll only face it once. Okay. So what is that? So the thing is, next is a node pointer. It's not a node. Yes or no? Okay, but this function, you're saying to the compiler, this function returns a complete node, not a node pointer.
So the compiler doesn't have to go.
No, what you need to do is change the return type of this function to say this function returns a node pointer. In other words, what it returns is not a node. What it returns is a memory address at which a node is contained. Does that make sense? Can you wrap your mind around it? So how would you say that? So get next returns a pointer. The contents of that pointer is a node. So how would you say that in syntax? Get next returns a pointer. Okay, and the pointer contains a node. So how would you say that in code? You have to change the declaration line on 21. How would you change that?
So
node star.
Yeah, where would you put the star? Yes, absolutely right. You have to put the star. Where do you put the star? Good, very good.
Would it be right next to get next, or would it be in place of the node?
No, I think it's right next to get next. That is correct. Okay, our first intuition was the right one. Okay, now is everybody on board so far? Everybody clear? Yeah. Okay, now let's do a couple of setters also like this. Okay, so after this method, hit enter, and then say bool set num. Okay, bool set num. Okay, and then this is going to take, because it is a setter, it's going to take a number and set it in the thing. Okay, so it has to say take int n, right? It takes a parameter int n. It takes a parameter int n.
So it's going to be in here.
Yeah.
Okay.
Yeah.
Int n.
And then n. No, n.
Just n. Just n.
Yeah. And then open the body of this function, and then we can open the body. We can write it right there, just like you've done with the other ones. No, not semicolon. You have to open the body. Yeah, braces. There you go. Okay, now here, what we'll do is do what setters really have to do, right? Setters should not be blind setters most of the time, saying, oh, here's a value, put it in the bin, and just go and bin. No, that is not what setters usually do. Usually what setters do, and the whole point of having a setter is that the assignment is a guarded assignment, meaning that if that bin can only hold positive numbers, and you say, here's a negative number, set it in the, put it in the bin, it's going to say, no, I don't do negative numbers. Yes? Okay, so that is why setters usually return Boolean type, saying, well, did I succeed or not? Right? So if you ask me to do something illegal, I'm not going to do it, which means I'll fail, right? I'll tell you I fail. Okay, so that's what we're going to do. So here we'll say if n is less than 0, we'll say if n is less than 0. No, it has to be within, yeah. if n is less than 0, yeah, return false immediately. Yeah. Okay. All right. So we're basically just not setting negative values. That's all. And now you can say, now we know that n is greater than or equal to 0 at this point. Now you can say num equals n. Return true. Is everybody okay with this so far? Okay. All right, great. Now let's do the same thing for next also, node star next. So get next and set next. What would be a good? Okay, here, this is what we're going to do.
So
yeah,
I just want to ask, so after the if statement, would you still need an else in order to make this return true, or it's just fine with the num equals n and then enter return
very good
true?
question, Jaden. It is a very good question. All right. In fact, what you've done there, if you look at that pattern, you'll see that kind of pattern in a lot of professional code, meaning that this concept of if n less than 0 return false, it is called an early return. An early return from a function means that you don't need to have an else below that. Because if you don't return, you're automatically in the else part. Yes, if the condition was true, you would have returned. Yes or no?
Yeah.
If the condition was true, you would have returned. Since you didn't return and you're still inside the function, that means the condition was false. Yes.
Right.
No, why is that valuable? Why is omitting that else valuable to professional programmers? Because as you write professional code, more and more professional code, you'll have lots of conditions, lots of nesting and while loops and so on, and your code will start getting more and more indented. Yeah. And sometimes you'll see some really serious code that is like indented 5 levels from the left margin. Now, every time you have indented code, this is my theory, okay? And I've not seen this theory proposed by anyone else, so you can test it out. My theory is that more indented code is harder to understand and assimilate because it assumes it results in more cognitive load. What do I mean by cognitive load? Cognitive load is when you're doing some task, okay? Forget about programming, okay? When you're doing some task and then you have to do something and then come back and finish this off, okay? Let's say you're baking a cake and then you find a missing ingredient, yes? And then you say, I'm going to go to Trader Joe's and buy this missing ingredient and come back, okay? So now you're in some other context. However, when you're in Trader Joe's, let's say you have even higher priority thing to do, right? And say, someone and says, well, or maybe you say, oh, you need to go to that store or something like that and come back here and then pick it up, right? Or you need to go to the ATM and pick up some money, whatever, right? So now the thing to keep in mind is that every time you switch from one task to another, there is a small bit of cognitive load, which, like, in quantum mechanics, the small things you can't notice, but it's there, okay? But you can only notice it if you have really, really, calm surroundings and you're completely 100% focused on what you do. You can actually see the cognitive load. And the reason is, but however, there is an experiment you can do to make sure to convince yourself that there is in fact finite cognitive load, because if you went from task A to task B, now task B you will find is slightly harder than a task B that you just approach directly instead of as a subpart of task A. Because when you're doing this as a subpart of a subtask of task A, you are really not ready to go home after you finish B. Yes? Because after you finish B, you got to go back and finish A. There's something hanging over your head, right? You got some pending work to do, right? Now, what happens if, when you're doing B, you got to do C? Then you got even more pending work to do, right? Because after you finish C, you got to finish B, and then you got to finish A, and then only you can go home. Now you can imagine that every time you indent in into your code, you're not free to go home until you reach the left margin. Your left margin is your home, right? And you can measure this in your own programming by doing something which requires like 10 levels of coding. and then detaching that part and separately coding it without the nesting, right? Saying this is a separate self-contained module. I'm going to code it on its own. When it's, fine and dandy, I'll take it and fit it back into the original piece and take it from there. Okay. Now you will see, right? You will personally feel the effect and be able to discern the difference between, wow, that's what happens when I work on code on its own, as opposed to as a subtask. Exactly the same code, but it's worked on as a subtask of something else. This is more strenuous and takes more effort, because 10% of your brain, or some finite portion of your brain, cannot be applied to the task. You're firing on 2 cylinders instead of 6, because the 4 cylinders are on reserve for doing the rest of the stuff after you finish this. Does it make sense? So in a sense, more indented code makes you work harder without your knowledge. And therefore, if you're just working on lots and lots of indented code, you'll feel fatigued more sooner, and you have to take a break sooner. That is my theory. Okay, so you can do an empirical experiment at some point to find out, if there's any grain of truth to it. And that is the reason. So that's a good question, Jaden, that you brought up. And that is the reason why you omit else's. Now, technically, you can put an else there, right? And you'll get the same effect. But you can imagine in your mind, at least with the else, how much more ugly it's going to look, right? So and I think the overarching principle here is just keep the aesthetics of it in mind and say, I'm just going to steer away from ugliness, right? And say, I'll just keep everything clean and elegant so I can look at it and get an instant picture of what's going on. And your code will actually be fewer bugs in it. Okay, so all right, so that is our setter. Let's do the setters, set num. Oh, you need to set next. Okay, we'll do the set next. Okay, we'll do the set next. However, I can't think of a possible situation in which you're going to be setting a next variable that will be illegal, because every address is a pointer. So we're just going to do a void. Okay, very rare situation in which a setter could be void is when you expect it to, it's a guaranteed success. Okay, so no, the next function. And in fact, let's put a comment on the setter, right? Put a comment on line 24 at the end, on line 24 at the end, right? And put a comment there, space 2 forward slashes, there it is, space 2 forward slashes, space, and say guarded setter will refuse to set negative values. SETTER will refuses to set negative values. Yeah, will refuse to set negative values. Does it make sense? Yeah, actually say make that a negative or n dash VE, right? Because otherwise set minus values. Yeah, dash VE. Yeah, no, yeah, all right. Oh yeah, all right. Yeah, negative, and get rid of the dash then. Yeah, because double negative might be positive, right? Mm-hmm. Okay, cool. All right, that's great. Now let's do our set next. Okay, set next.
You said do it in void, right?
Void, thank you. Yeah, I'm glad you remembered that. Yeah, set next.
Set next.
And this is going to
no. Sorry, are we going to need the star?
No, it's void. It doesn't return anything.
Oh, okay.
However, you're still going to need a star. You're going to need a star elsewhere, because the pointer that is being passed to set next is a pointer, isn't it?
Right.
Set next is going to get given a node pointer. So that's your parameter. So the parameter list for set next is going to take a node star P, right? It's going to take a node pointer. Yeah, inside the parameter list for set next, node star P. Star P. Right? Yeah, and the body of this is very simple, because you're not going to be doing any testing. You can simply say next equals P. That's it. Is everybody okay so far? So it's basically a class. It's something you create in the first 5 minutes to test something out. So that's your class. Okay, now let's go to our main and see if we can construct our roulette. Wow, some of your code, can you scroll up a little bit, because my film strip is obscuring some of your code. So if you scroll up and get the code to the middle. No, scroll. Yeah, there you go.
Yeah, just sorry, just
oh yeah, sure. Get main to the middle so that we can start coding main. Great, thank you. All right, so in main, let's just say yeah, all right, let's say a node star P Yeah, I think node star p equals new node. Okay, so new open close no new node new space new space node.
Oh, okay.
Yeah, node, and then semicolon right there. You don't need open close there.
Okay.
All right, so what that says is that no new node, that's it, semicolon right there.
Oh, just that's it.
Yeah.
Okay.
So it's just like saying new int, right? If you say new int, it'll give you a new integer, new long, new. So the difference between just saying int n and new int n is that int n will be an integer on your stack, a local variable. However, if you say new int n, that integer is not in your stack. It is on something called a heap. I think we talked about the stack and the heap before, right? So the heap is your terabytes of memory, not just here in your inside of your program. And so that it says, oh, you want an integer, but not in the heap. Oh, I'll give you the same 4 bytes, but it's on not in the stack. I'll give you the same 4 bytes, but it's on the heap out there. Now, because it's on the heap, this will not go after your program dies, right? Well, after your program dies? No, after your function. The function that is requesting it is done. That 4 bytes that was allocated to you is not going to be released back into the pool. It's being still marked as Jaden owns it. Okay, so anything you get with new from the heap needs to be given back to the operating system with the word delete. Yeah, so and we're going to do that today. Okay, so so that is our first node. Node star p equals first node. It's just unused variable. Okay, now let's do our yeah, I think we can do this. Okay, all right. So above node star p, let's create a constant variable. How many? Has anybody gone to seen the roulette wheel? How many slots do they have in Vegas? Like for these numbers, 100, 50, 75? Let's say 100. I don't know, 100. We'll start with 100, and then if the game is not so exciting, we can we can reduce the number to other numbers. Okay, so let's say const num slots equals num under uppercase all num underscore slots uppercase all uppercase because it's const, right? Num const int, by the way, const size t. I'm sorry, const size t. Okay, all uppercase num underscore slots. Okay, equals let's say 100. Okay, so we're gonna and then a semicolon and put a oh, in fact, let's put a comment above main. Okay, we'll say what we're trying to do because we haven't even yeah, put a semicolon after the 100. I think we'll just go right. Put a semicolon after the 100, and then no, we don't need braces at all, right? It's just a
okay.
All right, so go to line 35 and start a comment. No, line 35 itself, above main, we'll put a comment. Okay. Yeah, so we will simulate a roulette casino game. I think that's a spelling. I don't know. Someone can check.
Yeah, I'll check real quick.
Yeah. Okay. Yeah. All right. So now, so we have 100 slots in 100 slots where you can put your money. Okay. So all right. After line 38, hit enter, and we'll start our for loop. Oh, you changed it?
Yeah, I'm making sure it's spelled correctly.
Oh, is that the right spelling? I didn't know before.
Yeah, that's that.
Oh, so you have two L's and 2 T's?
Mm-hmm.
Wow. Yeah, I didn't know. Maybe it's not even an English word. Who knows, right? Okay, so 38. Hit enter on 38. Oh, you don't need you don't need a curly braces for node on 38. It's just
I thought
there you go. All right, enter. One more enter. We'll put a comment there saying we're going to fill up the num slots with numbers and link them up. Fill up the slots. We're going to fill up the slots and link them up in a circle. Fill up the num slots space with numbers and link them up in a circle. Okay, all right, great. So this is what we're going to do. On the next line, we're going to say for node star Q equals P, this is a new kind of for loop. Oh, why is it? No, it's not. we'll see. We'll see. Okay. Okay. Well, I'm going to make it easier. Okay. I'm sorry. I'm going to change this so that it's easier. I don't want to use a complicated construct. Don't say for. Say node star P equals Q there. Okay. Just say node star P equals Q. Semicolon. No, node star Q equals P. Semicolon. No, it's just semicolon and enter. You're very much a fan of open braces today.
Yeah, I keep my brain keeps wrapping it around that. That's a verb.
All right, so it happens. Okay, so enter. Now you're gonna say for size t I equals 0, I equals 0, I less than num slots. No. What do you put there?
Size ti equals 0, then it will be. Can't remember if it was coming.
Right? So Kate and Tim, you can also tell them what needs to be typed there. Take a guess, okay? It doesn't have. Yeah. You see, even if you say it should be a comma like Jaden, that's fine, right? We're just going to fix it. So take a guess and say what needs to go there. Complete the for loop for me. How about someone complete the for loop? Yeah. Go ahead, complete the for loop. Yeah.
So less than num slots.
Yes, thank you. Right. So, for example, in your quest and all, in quest number, I think 8, when you have to print only a certain fixed number of items in the stack, this is the kind of loop you'd use, right? For size ti equals 0, I less than 10, I plus plus, all right, and so on and so forth. So, all right. So, and then I plus plus there, right? Okay, so and then open, and now you can do your favorite thing. Okay, yeah, do your. And now you're not putting in a brace. Okay, where a brace is needed. Okay, good. Okay, overcorrected like a pendulum, right? So you go on this side and then it goes on that side. Okay, great. Now here's what we're going to do. This sequence of steps may take a couple of minutes of just digesting after we type it in. So I can give you like 5 minutes after we type it in, so that you can just talk amongst yourself about these lines of code and say, hey, do you guys tell me? Can you tell me? All right, so we'll type it out first. Okay, let me see if I get it right first. Okay, so what we want to do is Q arrow. Q arrow, Q, and then arrow.
Q, sorry, arrow?
Dash greater than is an arrow. Yeah.
Oh, okay.
Because Q is a pointer, you can't say Q dot. Q is a pointer to an object. If Q was an object, you can say Q dot get something, right? Q is a pointer to an object, so you can't say Q dot. You got to say Q arrow. That's the only difference. Yeah, it's the same object. Whether you're getting to it through a pointer or directly is what determines whether you use a dot or an arrow. Everybody okay with that?
Mm-hmm.
All right. So Q arrow, and you're going to say set num. Okay, set num. Just like you call, you don't need a space before set num, by the way. Okay, get rid of the space before set num. Yeah. So so just like you can access individual members of an object, you can also call individual methods that are attached to an object like this. Okay, now you're going to set the number on this node to some random number between 0 and 100. So inside of the parentheses, you need a random number between 0 and 100. Okay, so how would you do that? And again, Jaden shouldn't be the only one. Okay, Jaden, in fact, is the only one who's talking back to me too, right? I think I would like it if both Tim and Kate are vocal and participate, and you can also say, hey, type this and so on. So yeah, all of you. And it's okay if none of you know the answer too. I can fill in, but I want to make sure that all of you don't know the answer before I give it to you, because I don't want to spoil the fun. So
if I remember right, it's rand open close and then like percent. In this case, it'd be like 100 plus 1.
no, 100 is good, because we don't want the 3 digits. Because if you do 99 plus 1, it'll become 3 digits, right? So we'll say 0 to 100, 0 to 99 inclusive. I think that's good. Yeah. No, not 0, not 0 there.
Oh.
Yeah, what Tim said.
0. I mean, percent 100.
But I think is that outside the parentheses? Or is that right? Or sorry, outside
Are you or Jaden?
So it'd be rand and then open close and then percent 100.
Open. You said open close like this? I mean,
Yeah, like that.
Percent 100.
I think that's right.
Okay, that's it. Thank you. All right. Now here's what we're going to do. One small thing. Okay. Well, actually, all right. Just put a semicolon there, right? Now we want to put a comment there. Put the comment above 42, above 43, above this line, okay? Because it's going to be slightly longer, right? Yeah, put a comment there saying in the following, we don't check the return value of the following set because and the next line, open comment again. Because we know that the parameter is guaranteed to be positive, is guaranteed to be non-negative. Param, yeah. Is guaranteed to be non-negative. Does that make sense? Suppose you were sending a truly random number and you didn't know if it was positive or negative, then you'd say set it and then capture the value that's the set return, and then say, well, you know what, it's false, which means that number I gave it didn't get set. Does that make sense? Now, this is the way in which you can fish information out of closed methods. What I mean by closed private method, it's private. You can't see what's going on inside, right? You said, here's an object, do something, and the method came back. You don't know whether it succeeded or not. You don't know the state of the object, yes? Now, the return value is the only way we can actually find out whether it succeeded or not. Actually, that's not true, right? Because there's one more way, but typically this is the way that people use. Right, now we want to do the same thing. Well, hang on just one sec, set number. Yeah, okay. Now you say Q arrow next, Q arrow set next, Q arrow set next.
Q set space set next.
Yeah, and now you're going to set a brand new node, and you do that by open parentheses and say new node right there.
New
node. Okay, now this is a brand new node, not the place where Q lives, another place, another node. Okay, it created a brand new node in space and gave you the address where it lived. And you're saying, well, Q needs to point to that address. That's why you're saying Q, set your next to point to that new node. That's what that one line means. Is everybody clear on that?
Mm-hmm.
Great. Now you want on the next line, you want to say Q equals Q arrow. No, I think you got it. Are you using a device or a keyboard?
No, it's just I usually try to type
as
fast as I can, so I press.
Okay. Yeah. Because on my phone, on my device, sometimes I get Q instead of 1 when I type, because you know, on the Android keyboard, a long press gives you 1 and a short press gives you Q on the same key. So I thought that's what you were doing. Okay, all right. So Q arrows, get next. Okay, now this magic function, the magic loop. No, I shouldn't say magic, right? Open close, semicolon. All right. Now get to the end of line 48 and hit enter. No, line 40, end of, no, get rid of the blank line.
So you're saying like,
yeah, there you go. Yeah. All right. Now one more blank line and say one more blank line. And now we say that open a comment there. Open a comment there. And say this. We can say here that now P points to a node which is linked to a chain of 99 other nodes.
as a part of a chain.
No, it is the first. It is a first, isn't it? It's not part. It's not in the middle, right? So P is the first. So P is, or you can say now P is the first node of a chain, right? Yeah. Now you can say now P is the first node of a chain. Is the first node of a chain that has 99 other nodes. Now that part is something that you guys have to talk amongst yourself and convince yourself that's really what's happened, okay? Because the loop itself, I know it's very straightforward. If once you're in 2B, you'll just look at the loop and instantly know what's going on. But in 2A, sometimes it takes like 10 minutes, 20 minutes, a couple of hours even, just to digest that loop and make sure that that statement on line 50 has actually happened, right? So on the next line, you want to say, on the next line, hit enter, and we know that Q is the very last node. And we know that Q is the very last node. Yes or no? Because in every iteration, it's getting assigned to the next one. Yes?
Mm-hmm.
Okay. That means we can reset Q on the next line, on the next line.
Oh, okay.
On the next line. If we now make Q's next point to P, we get a ring. Yes? That means we can get a ring. Yeah. Oh yeah, we can. Yeah, we can get a ring by making Q arrow next point to P. Now Q arrow next point to P. Yes or no? So far, right? These I think the reason I'm pausing at these points is because these are all very subtle things that you're likely to miss, and high chances that you'll miss and then come back and say, oh my gosh, I got stuck. Okay, so it's better to spend a bit of time in making sure that this is solid. Okay, all right, good. All right, so now let's do that. On the next line, you say Q arrow next equals P. Oh yeah, Q arrow set next to P. Q arrow set next to P. And you have to, scroll up the code because it's, yeah, thank you. Scroll. No. I mean, push the code up in the window so that I can see. It's when you're typing, yeah, the lines below are behind.
Yeah.
Thank you. Right. So the parameter there is just P. No, not equals.
Oh,
so
inside
the parameter. Yeah. Right. Semicolon. Okay. All right. Now we have a ring of 100 random numbers. Yes or no?
I believe so. Unless something, unless we need more, unless it's not contained very well, and it might lose itself.
That's the right thing to say. Okay. In fact, what Jaden said is exactly the right thing to say. Whenever my professor asked me, is that right or wrong? He used to say, don't say it's right. It's right unless there's something wrong in it, right? So that is the right answer, because we never know. Something could be wrong, right? And so what you said, I greatly liked, Jaden, right? You never say that's right. You say, well, it looks right to me. Great. All right, thanks. All right, so I'll hit enter a couple of times. Well, let's think of something we can do with it.
Okay. Under line 53?
Yeah, line 54, one more enter. Yeah, on line 55, go to line 55, put a comment there saying, we write a loop, write a loop. This is, I think let's say this is a challenge for you guys, okay? Write a loop. It does or we write a loop to print out all of the 100 numbers, okay? To print out all of the numbers in the ring. Print out all of the numbers in the ring. You don't say how, don't have to say 100 because, we could change the value of num slots. You can say all of the numbers. Yeah, get rid of the 100, get rid of 100. Yeah. Okay. All right. Now, this is a challenge. Okay. And I'm happy to give you 15 minutes. What time is it now? 9:12. Okay. I can resume the rest of this. I think there's not a whole lot left. Okay, at 9:30. And most likely you guys will be done before 9:30. This is a very simple thing. But no, I shouldn't say very simple, because there's a lot of scope, a lot of scope for you guys to go wrong here. Okay. And have it not work. I want you to fail. Okay. Not in your exams. I want you to fail with this implementation in the next 5 lines, so that you fail now. Okay. Not later on when it's going to be dangerous. Now, if you fail, I can watch and say, hey, okay, that's why it failed. Now you'll never fail again in your life. Okay. So I want you to fail doing this thing. Together, the 3 of you, I think with the 3 of you that I see on screen, there is more than enough talent. Okay. So there is, because, maybe 1% you could say, well, I'm not so confident, I need your help and so on. Okay. I see the 3 of you. I know how much each one of you has progressed, because I'm every single thing that you've typed and submitted into the question system, every line of code you've typed, I've actually looked at. Okay. And I know from an assessment, from my experience of teaching many, many students in the past, I know that the 3 of you have enough knowledge in you. Right. So I wouldn't say this if, some newbie was here, first lecture they ever attended, do this. No. Right. I know that you guys can do this, but it'll probably have an error. And in fact, hopefully it'll have a serious error. No, it won't have stupid errors. Okay. It should have that serious error that I'm hoping it'll have. Okay. I'm hoping you'll make that serious error. So write a for loop or a while loop or any kind of loop you want. And all you should do, that loop should do, is to print out 100 numbers, each one in you can use get num. Okay. For as you iterate through the nodes in the ring, you can use get num to get me the number, see out. Get me the number, see out. Well, obviously you can't do that. Get me the number, see out, and then that node should go to the next one. Then get the next number, print it out, next one. Okay. And you got to do that for all of the 100. Okay. You should do that without resorting to the number 100. Okay. And starting at P. No, you cannot use the number 100. You cannot use the word num slots. Okay. You cannot use the word num slots. All right. Put another comment on that line. Okay. Put the challenge. Okay. One more comment. Okay. And say challenge in uppercase, challenge. Okay, colon. You cannot refer to num slots. You cannot use num slots or 100 anymore. Uppercase num slots or 100. Okay. Hey, that's really cool. I just thought of this problem. Well, actually, no. Morning. I think so. I think I already thought about this morning. Okay, not just now. I thought I just came up with this idea. All right. Okay. All right. So that's what you got to do. Okay. Are you guys comfortable and confident that you can tackle this in the next 15 minutes? Great. Thank you. All right. Do this. Run it. Have it work. And then if it doesn't work, I hope to see conversation amongst you guys. Okay, saying, hey, it's not doing what it's supposed to do. What are we doing wrong? Okay. So Kate, are you back at the keyboard? Yeah. Okay. All right. So the 3 of you now. The 3 of you now are going to do this. Okay. It's going to be like 4 lines or 5 lines of code using a for loop, and shouldn't be Jaden only. Okay. All of you guys, and you should be doing this. And when you're done with this, let me know. Okay. I'm just going to be here and I won't be looking at you, so you don't have to feel your style is cramped. But I'll be listening to you in case you call out my name. But that you should do. Okay. So do it now. Is that okay with you guys? Thanks.
We're writing we have to write a for loop for this one, right?
Sounds like it, yeah.
And we can't use num slots or 100. Would it be cheating if we use like something like I is less than 101 in this case?
Yeah, probably.
Yeah.
right, so this is, we know that Q is the very last node, right?
Right. Q
We
is supposed
can
to be the last node.
say while Q is not equal to,
So it's wait. So we start with while, or
I'm thinking like a while Q exclamation point equals, I think so. Let's create a check.
sorry, did I put that right, or does the exclamation point come before?
Before the equal sign.
Okay.
Before the equal sign, so it'd be Q
Oh.
exclamation point equals, and then whatever it's checking against.
Q. So Q exclamation point equals. Tim, I think you might be muted right now. Can you guys hear me?
Oh yeah, I can hear you.
Yeah, sorry.
The two is, I don't think you need a space between the exclamation point and the equal sign. I might give it a
Okay.
here.
Exclamation.
Checking. So I'm trying to. So I'm just a little confused on the ring here, right? So what are the nodes stored in?
Yeah, so what I don't get is it looks like num slots is an array. Wait,
Sorry, I can go up.
num slots an array.
Num slots, I think, is our integer, like just number of,
I see.
what do you mean lowercase?
Oh, it's just 100. Yeah, like I don't know what they're stored in.
So you have an integer num and a node.
We have are they? We have a defined num slot const size t equals 100, and then in the for loop we say that I would have to be less than num slots in this case.
The
Yeah,
for,
like where do they go when you make a new node? Where does it go?
yeah.
So then, because if you know where it goes, then you know how to access a specific one. Like if it was in an array, then you would just like go to that specific one in the array, right? But I don't know where they're going.
Yes, the class node has next and num. So it would be the num square brackets well, I guess it's pointer.
I don't know if this is a dumb idea, but for Q set num rand, wouldn't it be better to, instead of using the 100, it would just, since num slots is going to be equal to 100, would it be better to just put num slots in?
You could do either one. I don't think it really matters.
Yeah, it
but
doesn't really matter
like
to me.
Okay.
Doesn't change anything.
So our node is star Q.
Hmm.
Or oh wait, no, star P. So he's talking. Do you, Kate? Do you know what the heap is that he was talking about?
No, I do not.
I don't either. I think that he's talking about node star P is a new node, and it's on the heap. I put a little note there just for myself.
Hmm.
So the heap is like all the. I'm just kind of talking out loud here now. Not actually. I don't know what I'm saying.
Let's look it up.
So now P points to a node.
Okay. Do we don't in this case also in set num we don't need the 1 plus rand, right? We just need it rand.
Say again.
For set num we don't need it, we just need it as rand percent 100. We don't need it as 1 plus rand percent 100.
No, because he said he didn't want a 3-digit number. So like if it's percent 100, it's never going to be 100. It'll be like 0 to 99. I thought it would have made more sense to do 1 to 100 or 1 to 99, but I think yeah, 0 to 100 is fine, or 0 to 99.
So sorry, if I could ask, what is the Q exclamation point doing exactly?
Well, okay, yeah, I was just thinking about that. I don't know if that's the best way to do it because we don't know where to start, but we know that the chain of pointers is connected to Q as of like the last thing that the professor wrote there.
Mm-hmm.
So actually, instead of doing a while loop, you can scrap that. The exclamation point equals, that's just saying like it's not equal to this. So like it's true when it's not.
Okay.
When Q, like basically if we were counting up to Q, we would have, we wouldn't have stopped the while loop until we reached Q basically. But yeah, so if we get rid of all that.
I think if we use a for loop though, we're gonna have to use 100 or num slots. So it kind of has to be a while loop.
Yeah. Like, okay, so like there's the fact that we're setting all the nums in the pointers that he said it's guaranteed to be non-negative.
Hmm.
So I guess anything beyond that isn't. I don't know if that's a good way to do it, but so we could like say while the value of num is greater than 0 or greater than or equal to 0.
Would it ever end? Like, would it just go forever?
I don't know. I can't think of any other way.
Well, I mean, he said not to use 100 on num slots. You know, like I said, we could be less than 101. It would still count. Yeah.
I guess, but like I think the while loop is a good idea. We just have to know what we're checking.
So, sorry, while num. Did I put that? Am I putting that in right so far? Or?
So num is a private member of the pointer, right?
Mm-hmm.
So we'd have to, it'd probably be actually get num p dot get num or
Wow. P dot
star p.
get
I'm not sure.
num. Sorry, what was the symbol again?
It might be star P, and I think getting them needs an open close parentheses also. Although wait, no, star P is the node, which is what we want, I think. Well, that looks like that might work.
Should I use a star instead, or should I leave it as an arrow?
I mean, let's see if that works, I guess.
Okay.
Wait, so what does that say? While the arrow, what does the arrow mean? Isn't that a pointer? Or
I think when it's a pointer, use the arrow to access it instead of just the period.
okay. Okay, gotcha.
Yeah, so it's the same thing as like p dot get num.
Got it. So Jaden, you want to make that while it's greater than 0 just for testing? I don't know.
Okay.
Yeah, we'll start with that. And then we can end it somehow, but we'll just like fill in the body of the loop.
And that's going to be inside the bigger parentheses.
Yeah.
Yeah. I accidentally put that there, so greater than 0.
So what we're checking in the while loop is yeah.
P. P goes into get num.
Get the next one. So it's P get next.
P arrow into get next.
What do you guys think? And then maybe a C out.
In the same line, or enter C out.
Yeah, probably right there. Same thing would be like get num of P. It's either P arrow or P dot. Get num.
Oh, P arrow into get num. P.
And don't forget you need the double arrows for C out, I think.
You said, wait, double arrows?
I think so for that one.
Yeah.
No, the left.
Yeah.
You know, when you do a regular C out, you have to have the double left arrow.
Oh, are you talking about this?
No.
Yeah.
Sorry.
The lesson sign.
Sorry, I'm getting confused.
The double left hand sign. Yeah, remember?
Okay, so now after the C out, it's to the arrows going to the left, but not like a full arrow, like just the less than symbol.
Yeah.
Oh, sorry, you're talking about like this. Sorry, oh god, I'm so.
Maybe
this is that coding fatigue he's talking about.
Fine.
I get it.
Let's see. It's saying it's expecting expression at this.
Yeah,
Oh, colon. Yeah.
colon at the end.
Yeah.
I have no idea if that's going to work or not.
Well, yeah, because it's never gonna end. I also actually.
Wait, isn't there a way to make it end?
Break break semicolon, but then like it's just gonna break on the first one.
Yeah.
Maybe if get next, if you use get next and it's equal to Q, whatever in Q, then you break.
So this is before or after the C out?
After.
Okay, so you said get next.
Yeah. So if get next, but it's not if it, well, it would be like an if statement. If you use get next and you get Q, then you know it's the end of the loop, and then it would just break there.
Well,
If
are we sure that's gonna work though?
No.
I almost, well, I guess we haven't really said anything.
Just- we just need some way to check if we've gotten to Q, right? But I don't know how you would do that.
Because I kind of, maybe I'm just imagining this weird because it looks like the last thing that the professor wrote, the Q arrow get next. Like, where does that put us in the chain? If you visualize the chain, are we like right next to Q?
why is it saying that?
Are we going the other direction? I don't know. Yeah, you have to specify where get next is. So probably P arrow get next.
Oh, right. The arrow. Dang it, why do I keep holding that down? Easy. Expression is not assignable.
Double equal sign to compare.
Mhm.
Yeah, starting bracket. There, yep.
P, so P to get next equals 0. Did we break the for loop at that point, or?
Will that break the if loop or the for or the while loop? I always had trouble with this logic.
Hmm.
Do you know if you put a break right there, will that break the if loop or the while loop? Actually, the if isn't a loop, I guess.
Ooh.
I guess we could test it out.
Yeah.
Yeah, so put in a break right here.
I guess if isn't a loop, so maybe that'll work.
Yeah, I think it would break the while loop.
Oh, so that's right.
Get anything? Ooh.
Okay, that's spazzing out. Hold on.
Are we getting an infinite number of sevens? Is that what that was?
Just- So what's happening here? Okay, so it prints out these infinite numbers of sevens and then breaks itself.
So I feel like we're not progressing to the next number somehow. And the one we're checking is like a random generated 7 or something. It's just printing that same one.
If we let's let's see what happens if we run it while it's still. See what happens if we run it while it's just this.
Yeah.
Okay. And then it just disappears again. So what's causing? What's causing this to make it spawn if the numbers are the same number? Sorry, just let me see what happens if we just run it without the while loop.
There's no CATs.
Oh, right, there's no CAT. So, okay, let's just put everything back there.
Let's see. Yeah, get all that back. Can you try like a star P to get next? Like, is that not get get next?
So, in the while loop or in the for loop?
Right there. Is it? Because all these times that we're using P arrow, are we referencing the value at the end of that to where it's the value where it's pointing? So like if we're trying to, because before we finish this while loop, at some point we need to change. We need to change where we're pointing because it's pointing to the same number. It looks like. I don't know.
So you're saying, sorry, do you want it in the if loop or P for P got next, or do you want it in the while loop for the star?
I don't know. I'm a little lost now. Where? I think like right after the if statement, maybe we need to set next. No,
Set next.
No, it's going to change it.
Do you guys want some help?
Maybe in the interest of time, can you?
Time? Okay. Yeah. Okay.
Yeah,
that's what I was hoping to hear. Okay. Thank you. All right. Because I don't mind if we don't complete this today. We can still work on it first class of next week. Okay. Tuesday and Thursday, we still have time. And if, I don't care. Even in week 12 or beyond, we can still continue to meet and wrap this up before your CS2B starts. Okay. Or we can do more projects too, right? More projects involving linked lists and pointers. All of that is perfectly fine with me because I got time. So I'm happy to hear that you guys want to fix it yourself. So the only, do you want some tips before you take it on again?
I think we have an idea of what we're doing here, but I was hoping maybe you could explain to us like what we currently have, what we are currently doing.
Sure. All right. Can you scroll up a little bit? But move the code.
Sorry, just
yeah, that's fine. Thanks. All right. So what are you doing? Okay. P next. Greater than 0. Okay, so that while loop is never going to terminate, right? Because we made sure, oh no, it'll terminate on some random node which has 0, because we don't know that, and also more than one node might have 0 in it. Yes, because we're just picking a random number and putting it in these boxes, right? So more than one box might have 0. Yes or no?
Yeah.
So that would not be a good condition in the while loop. So that's one of the things that you can make a note of and fix. The second thing I noticed is that get next returns a value. Yes, it doesn't change anything in the object. The get next, does get next change anything in the object itself? No, right? Because in fact, if you look at the signature of get next, it says const at the end. Yes, const means I'm going to do something and read something and give it to you, but I'm not going to change the object at all. That's what const means. Yes.
Yeah.
So by calling get next on an object, either through a pointer like P, like you're doing now, or a node, you're not changing the object at all. The only thing you're doing is getting something out of the object. So you've got the next, but you've just thrown it away on line 58 because you're not assigning it to anything. Yes? So you got next, you got to assign it to something and hold on to it now, because that is what you're going to do some work with. So that node which you've got and holding on to, that number you can print. And then that next, the next of that guy is what's going to be the current node in the next iteration. Yes. So here's the, so I'll explain it pictorially and you can code it up. Okay. Is that okay? I'll pictorially with my hands. Yeah, is my hand in the frame? Okay. Yeah. Okay. All right. Okay. So this is the ring of objects. Okay. This is the ring of objects. We have lots of objects. Okay. P, Q, R, S, T. All of these. These are all objects. Now you're going to start at P. Let's say you're going to start at P. Okay. And starting at P, you're going to get the value of P using get and print it out using cout with a new line after that. So far, you're good, right? The next thing you have to do after that is that you're going to loop back to the top and you're going to do the same thing, except P is not the same P anymore. P should be P's next. So print the value of P and then change the value of P so that P is P's next, and keep doing it in a loop. That way you'll print that, and then the next node, P is now this. You're going to print that and change P. P is now that. And you'll do that all for all of the nodes. And at some point, you're going to come back to the top, right? And that's when you got to stop. Because if you don't stop there, you're going to keep getting stuck in that infinite loop and keep doing that forever and ever. Now, how do you figure out where to stop? And that's the problem that I want you guys to get stuck on. Okay, I want you to get stuck on that problem, saying, how do I get out of this loop? Because you're not going to be using numbers. You cannot use numbers in your comparison. Okay, you can't use if n is less than or greater than, or get num is greater than, less than. No numeric comparisons. Okay, no numeric comparisons allowed in this loop. You know, put that after line 56. Put a comment there saying, yeah, no numeric comparisons allowed in this loop. No numeric, N-U-M-E-R-I-C. Oh, I see. Did we already have a numeric comparison? Yeah, okay. No new. You're right, Jaden. Say no new numeric comparisons because we already have one comparison, right? P next get next to 0. Okay. No new. No new allowed. Okay. All right. So that's all the information I have to share, and I haven't shared enough information to make you succeed yet. Okay. So there's still that place where you're going to get stuck in a loop. Right, so you got to get stuck in that loop, and then you'll figure out how to get out of the loop. Okay, so I'm glad. I'm so happy to hear Tim say that you just want more time. That is the right answer, and that all the top software engineers I've worked with, when I go into the room or a team meeting and say, hey, are you guys stuck? Do you want some help? They say, the top software engineers will usually say, no, we just need a little bit more time. So that is absolutely fantastic. So thank you. All right, so I'm going to turn the laptop around one more time. All right, so you guys good with that? And don't worry if it goes all the way to the end of class and you guys have to drop off. Save the code, Jaden, okay? You got to save that code, post it in Reddit, along with what you're trying to do, and ask for help from other people like Chongwan and all these other people who are going to look at the code. Shadi, who's not here. You can ask for help if needed, but try to get it all done before the weekend so that on Saturday when we pick it up, we can make some further embellishments, turn this into a real game on Tuesday, and see where we can go from there. Okay, so thanks, and I'm going to be here. Okay, anytime you're irretrievably stuck, just call out. And I had a great time just listening to you guys. So thank you. All right, so just do that.
Okay, so no new numeric comparisons allowed.
So like you said, I think we need to save that P get next into an integer that we can use in our while loop, maybe.
Yeah, so on line 59, Jaden.
Yeah.
If you want to just like make like an int x equals
There we go.
Now we have that saved.
Now initialize a
Node. Oh, maybe node X
node X.
instead of int.
I think we need,
Oh, okay.
So we have a temporary node that we're working with.
Well, P's already a node, isn't it?
mhm.
That's why it's not working.
Because you make it node star X, but then like you're saying, we're kind of just creating something we already have.
If we, I think we should keep it an integer because
Oh,
we would just have to, when you use get next,
Allowable conversion from node to end.
we're trying to save the integer of the next value.
scroll up to your get next.
Yeah.
You see that? Oh, it returns node. Oh, okay, I was thinking of get num, but
Hmm. Um, so we have- It's just so hard to picture when you're dealing with pointers. I don't know why.
So are you saying that it shouldn't be get next on, or does it have to be get next right here?
I mean, I think it it does have to be get next, but we just have to store it somehow. But it said we can't convert from a node to a node, or like we can't get we can't make a temporary node.
Remember, you can make a temporary node pointer.
That's what I'm trying to.
All right,
Yeah.
let's try that.
How would we save the pointer?
Instead of in X, you want to put node star X and then no star in front of P.
Node. Like node on the star or node on the X?
On the X,
Star on the.
we're making a temporary node pointer.
There we go.
Node star X equals.
I don't know if you need that star in front of P.
Yeah, probably not.
Okay. All right, that looks like that worked.
Now, so are you saying now that we can put instead of a 0 we can put an X? Or do
Well, because it's always gonna be equal to X since we're setting X equal to get next.
okay.
So we want if X equals, I don't know, Q. Also after the C out, I think we have to say that P is now equal to P get next, so that when it goes through the loop again, it's the next P instead of the same P.
Oh, so P will be equal to P?
Yeah, P will be equal to P arrow get next. I think, because then that would just turn it into the next one, right? And then let me go back through the loop.
So if X will equal.
Unrelated, but one thing the professor noted is that in our while loop, instead of greater than 0, it should be greater than -1 because we're going to have 0.
Mm-hmm.
We're going to have zeros in there.
So would it be X equals to P for the if loop or no?
No,
How would we make
it's not equal to P. I don't know what it's equal. It's somehow, well, it has to be equal to Q, but I don't know if you can just do that. Like I don't know if you can just put Q in the. I don't think, yeah.
Double equal sign, by the way, to compare.
But can you do that? Like, can you just compare two notes and
Seems that it's allowing it.
I mean, I don't see why not. If they point at the same thing.
mm-hmm. Okay, well, we can see what
I
happens.
See, it stops.
Let's put a space after
Yeah.
this out, just so yeah.
And Endel and that CO statement.
Yeah.
So
And
you
you
said space or
no, after get num parentheses, 2 more arrows and then endl. After get num. Yeah. Other direction, I think. Yeah. Endl.
right, and
Yeah.
okay, let's see if I cleared it up.
Does that look like 100 numbers?
Yeah, how far does it scroll? It's like about 100 numbers to me.
Yeah.
Or maybe a
I
little
think we
more.
got it.
That looks like a very long list.
I don't know if there's an easy way to count, because if it's more than 100, we might have like started. Oh, never mind. I'm not gonna say something.
It looks right.
Yeah, it looks about right.
Okay.
We have the we should have a
Okay, well, it makes sense. If X equals Q, then it ends. I feel like it should be more complicated than that.
maybe.
All that stuff he was saying. Stuck on there.
So should we check it out with the professor?
Yeah.
Anand?
Yeah, ready?
Yeah.
Maybe.
Okay, let's take a
Yeah,
look. Oh wow,
the-
look at that, Okay, cool. Let's take a look at the code. All right.
So this is what we ended up doing. So I'll
Okay, so while you're still why would it be 0 or why would it be -1 at all? It would never be -1, right? So the outer loop does not have a termination condition,
Yeah.
right? Okay, that's
so
okay. That's okay. You got it working. So let's see. Okay, x equals p is next. You print out the value, and then you say p equals get next. X equals q. Oh, I see. You are holding on to the last node. That's your q. You haven't forgotten q. You're holding on to q, and then you're starting from p, and saying, okay, I'm going to print all the nodes until I hit Q. Yeah, okay, that is the right approach. Okay, excellent for coming up with that. Because we're going to make some minor tweaks here. It'll take 2 minutes. Okay, minor tweaks just to improve the code lightly, and so you can think about it and talk about it in the forums. Okay, all right. So the first thing I want to change is that no new numeric comparisons allowed. Okay, so you have a comparison with -1, so that's not allowed. Okay, so here's what we'll do. And but the thing is, I want to preface this, right? As soon as I say this is how we do it, you're going to kick yourself, kick yourselves in the back and say, oh my gosh, why didn't I do it this way? This is so straightforward. So you want me to tell you, or you want to talk about this in the forums, and then either way is fine.
Sure.
Okay. You want me to tell you? I can tell you now. All right, good. All right. So here's what we're going to do. After line 57, hit enter.
Sorry.
Yeah, hit enter. All right. Now, forget the fact, because after that loop, we don't know where Q is pointing, essentially. Because, we did something, and so let's not take it for granted that Q is pointing at the last node. So let's always start at the very first node. Yeah. So that's, it's systematic, isn't it? So let's say Q equals P here.
Q equals P.
Yeah. All right. Enter. No, so you need a semicolon, right? You need a semicolon. Enter. Now you can do your hang on. Q equals P. And all right, here we are going to do what is called a do-while loop. This is a phrase. Have you used do-while loops before? It's actually a very good opportunity to use do-while loops. It's a new kind of loop where you're going to have the same kind of testing, except the testing happens at the end, not at the top, right? So what is the advantage? Because all languages give you top tested loops and bottom tested loops. Now, sometimes you have to use a bottom tested loop because you want to execute the loop body at least once. So meaning that if the test is at the bottom, you're going to do this at least once and then test it and exit here, right? If the test is at the top, you may test it and exit and never have to execute the body even once. Yeah, okay. So now what we're going to do is say do and open brace. You can actually do it with while too, right? So you can do while, for, all of these things will work. So, but we'll do it with all right, do. And here you're going to say see out line 64 that that Kate or you guys typed, right? Just copy line 64 in there. Triple click. Yeah, all right, that's fine. Okay, now on the next line, you're going to say P equals, hang on. Not P arrow get num, it's Q arrow get num, right? Q arrow get num, and also put some spaces around the shift operator, and get rid of the space after the arrow too. No, that was okay. Get rid of the space after the arrow. No, not that arrow. This arrow.
You said.
Yeah, there you go. And then a space after the CO. Yeah. All right. So it's everything is clear, and for students who are looking at it, after the CO, after the CO, put a space.
Oh.
Okay. On the next line, you're going to do on the next line, you're going to say Q equals Q arrow
Q
get next.
Arrow get next.
Yeah, enter. Semicolon, enter. You got to get in the habit of terminating statements with semicolon. Okay. Now get rid of the line 62. You don't need the line 62, and then go after the closing brace. Yeah, on the same line as the closing brace. Space. While Q is not equal to P. I think that should, yeah. Well, Q is not equal to P. Yeah, spaces around the not equals. Yeah. Oh yeah, no, spaces around. Yeah, there you go. Get rid of that space, and put a space before instead of after. Yeah, there you go. Okay, and then a semicolon after that at the end. That's it, enter. Now, that's it. That's all you need. Okay, that should work.
It's getting an expected expression over here.
Yeah, because that is not, because we messed with that.
Right.
Comment out 64 to 71, right? That code, what you guys wrote was also, I think, pretty good. But these 4 lines of code should do exactly the same thing. And figuring out the logic for those. Oh, here, no, don't do this, right? Command Z out of it. I'll show you an easy way to do it. Okay, Command Z. All right, get rid of that too. Yeah. All right. Now, one more backspace. Okay. Now select line 64 to 71.
64 to 71.
Yeah. Okay. Now right click and say comment region, or right click. Does it say comment? I think you can have it in, I think maybe it's there in the edit menu or something, view menu. There is Xcode has an option to say, here's a block of code I've selected, make them all comments, and Xcode will automatically put the slashes for you, right?
Does command backslash work in that one too?
Oh, is it backslash?
I think it's command backslash.
Try command backslash.
Backslash. Let me see.
Or maybe command // one of those.
1 and 2.
Oh, command Z. Right, command //
//
Maybe not. I'm not sure.
That didn't work. I make that a block comment. Go to line 63, hit enter.
Line 60.
Yeah, enter. Start a block, enter. Block comment, meaning slash and a star, slash star.
Oh, slash.
Star. And then go to line 72, hit enter.
72.
Now star slash. Okay, that's it. All right, so that code has been commented out. So the only code that's active is the code above it. And so my claim is that should in fact work. Let's run it and see if it works. If it doesn't, there's a bug that you guys have to figure out because we're at end of class. Did it work? It worked. Okay, cool. All right. So I hope that the logic in that tight loop is clear enough for you guys to basically understand and also explain to other students who may come asking when you post this code, Jaden. Some students may ask, hey, how does it do it? That part of the code, 58 to 62, what the hell is going on there? So I want you guys to be totally comfortable so you can explain it to them if they ask. But are you guys comfortable with what's going on in that loop? Yeah, it's very simple, isn't it? It's very simple because you're just holding on to something and saying, well, I'm going to print it, go to the next one, print it, go to the next one. But at the end of each print, I'm going to test if the next one is the same as what I started with, which is P. If it's the same as the node that I started with, I can exit. So this way you've done it without any more numeric comparisons, right? No less than zeros, greater than zeros. You don't have to mess around with any of that nonsense, right? So, so this is a cool and most common way in which people iterate through linked data structures. Whenever you're iterating through linked data structures, just keep this in mind. It is not a good idea to iterate using counters. This is very rare cases where you can use a counter to iterate through a linked data structure, like that, and keep count, like IJK, very rare. So if you find yourself doing that, it's a good opportunity to step back and say, wow, okay, I find myself using a number or a numeric value to step through a linked data structure. Something is probably wrong. I'm going to look at my code and see if I can fix it. Okay. And 99% of the time, you'll find out that it's possible to do it without maintaining that counter, because the linked data structure automatically encodes inside of it, all of the conditions you need. It's just a matter of finding out. Now, this is a way to find out, to go through that entire loop, isn't it? Right? So it's go through an entire loop and stop. Now, if someone asked you, gave you a linked list and said, tell me if this is a loop or not. Tell me if this is a ring or is just a string, right? Is this a ring or a string? Meaning that, is the last one connected to the first, or is it like that? Now, how would you find out? Now, one way is to do this, right? One way is to say, I'm going to hold on to this node and keep going all the way for maybe 1 million nodes, or how many ever they say that's the longest string you can have. I'm going to keep doing that. And if I find a node that is the same as what I started with, that is a ring. Now, is that a good way to find out whether it's a ring or it's just a string of nodes?
Yeah.
Yes. However, okay, Here is another problem, which is exactly the same, but it is incredibly more challenging. Well, I don't say it's super challenging. There is a solution, and it's a very elegant and beautiful solution. It's beyond CS2A, but I think it'll be nice if you just think about it. Doesn't matter if you don't find a solution, but keep thinking about it. Maybe in 6 months, you'll find a solution on your own, because you can always find a solution. Go to Google, you can find a solution, right? But if you just think about it, you can't find the solution, just write it down on a sticky thing and put it on your fridge, okay? And just look at it once a day, just once a day, and say, hey, and then all of a sudden one day you'll have the solution, and think about how long it takes. And you will find the solution yourself. Now, the problem is, in this case, where there's a simple loop like that, you found there is a loop. What happens if I give you an arbitrary filament? Okay, arbitrary filament that is, any number of lines long, huge. It could be many, right? And I said, find out if there is a loop in this link. Okay, there is a loop. So meaning that you could have a linked data structure like this, all the way for 5 million nodes, and then there's a loop there. Bam. Okay, and it doesn't come all the way to the beginning. In this case, you had a ring, right? But in the other case, you may just have something like a ski sled or something like that. It goes like that and touches the linked list somewhere else. That's also a loop, isn't it? Because if you think about it, you go P, the successor, so on, so, right? And here, and then that's the Q, which is supposed to be the last node, but instead of Q pointing to P, it's pointing to somewhere here. So your loop is not this, but your loop is this. Here, your loop is here. So what happens? What happens if I give you a long filament, right? A long list of links, and say your problem is to find out if there is a loop anywhere in here, not necessarily a loop coming back to the first node. Yeah, because if it's the first node, you can always hold on to the first node and say, right, is any of my next guys pointing to the first node? Then it's a loop. Yes. But if I told you it's got a loop, but it's not the first node, it could be pointing anywhere in there, right? How would you find out? How would you find that out? Don't you think that is an incredibly interesting problem? And it's also a hugely useful and real problem in life, not life, in programming, because you take internet crawlers, okay? Take Google, for example, and they have to crawl the web and find out, these web pages that link to other pages. That page links to another page. Click, 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 click. Right now, what happens if the Google spider, which is basically crawling the web, looking for all of the different pages, gets stuck in one of those loops? Right? This page points to that. That page points to that, and this page is pointing back to the same one. Now, how can the crawler distinguish between I'm getting stuck looking at the same set of pages again and again, versus I'm actually looking at different things, right? No loops at all. So these are graphs with loops, and graphs that don't have loops, like spanning trees. They're called spanning trees. So how would you find out? Now, that is actually a challenging problem. In fact, it is so challenging. I shouldn't say it's challenging, and it's not an interview problem. Okay, let me put it this way: it's a challenging problem. And with an easy solution that is not an interview problem. And the reason I say that I never ask this in an interview, because the solution to this problem is not something that just comes about, by brute force. The solution to that problem just comes by looking at the fridge magnet for 5 weeks or 10 weeks or however long it takes, because the solution has to come from outside. So that is the way. It is some mathematical knowledge also, maybe, right? That is the way I can detect loops without having to remember. Because the only other way you can tell if there's a loop is that you remember every single node that you cross. Because you find a node that is pointing to some node that you've already seen, then you can say there's a loop. But if you have a million nodes, you got to remember like a million points where you can point back. Yes? And that's not a scalable or tractable way. If you have an infinite number of nodes or 10 trillion nodes, that's not even going to work, because every node you got to check 1 trillion predecessors to see if it's pointing to that. So definitely not going to work. So how can I make it tractable without having to remember all of my predecessors? Okay, that is the great challenge. And I'm glad we actually got to that by the end of this class. It is an open problem. No, it's not open, meaning it's got a solution, right? I'm not done math open problems like everybody, even researchers are working on it. No, this has been solved. And so that is why I say be very super duper cautious not to look up Stack Overflow or Google saying, how can I find a loop in a list? It is okay if you don't find the solution for the next 6 months, but it's important that you find it on your own, because the problem is actually, if once you think about it, like I said, after I showed this to you, you're going to kick yourself in the back, right? Because this is actually quite simple. If I gave you more time, Tim said, because it was end of class and all, we did this, but I'm pretty sure that if you had more time, you would have, come to the same code. Well, maybe not, because we didn't cover do while loops, but still you can do this even with for loops and other loops. You would have come up with the same solution eventually, right? But this is basically the structure. Now, was this useful to you today, this class, right? You guys did a lot of coding, and thank you. Yeah, and I think this was useful practice too, right? So to play around with linked data structures and get to know more. The challenge really is getting to know these data structures intimately, because you don't need to know data structures intimately to pass a course and get a paper certificate, and which most of you will know from doing other classes too, right? You just pass, you can learn how to do this and write it, but intimately knowing this is the way that you can actually relate to the data structures much better, because once you know a data structure inside out, that data structure will start serving your needs, because it'll say, hey, right, because you know everything, and you can ask it to do things that are good for the data structure. Good meaning it's are easily doable by the data structure. And what I see is that is many times in code out there, people use data structures and get stuff done, but by selecting the wrong data structure, you will ask it to do things that are not its forte. So you will ask the data structure to do things in a hard way or inefficient way, and it'll do it because it's inefficient, right? So from an outside perspective, you won't know. It's just working, maybe it's slow, or maybe the system is slow and things like that. No, the problem is that the program was inefficient because it used an inefficient data structure. It's just a management problem, right? So good managers will select the people that are best suited for each task, right? You may have the same set of people in your team as another manager. Exactly the same resources, but a good manager will say, now you're really strong here, so you go there. You're strong here, you go here, and they'll fit all the people in the right places, and everybody will be happy, productive, and the job will get done, right? But the same number of people, a bad manager will say, you're good at this, you go work on something else. You're good at this, work on something else. Okay, well, maybe they'll learn things, but it's not going to get the job done. So that is exactly the way you are basically trained to be top quality managers, by understanding the data structures well. Just like top managers do their jobs well and get execution happen quickly by understanding their employees, right? Not by saying, you guys, all of you, you're working for me and I'm paying you, go and do this shit, okay? That is not a good manager. A good manager will say, tell me about yourself. I want to understand more. What tickles your fancy, so that when I get some stuff that I can partition it and give you the part that you'll enjoy, right? And that is where you're going with data structures too. And your goal here is not to say, well, you can, the dictionary can do this, linked list can do this, a tree can do this, okay? So and they can all do everything most of the time, and say, well, I got these fancy tools and I've got this job, bam, 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 okay, do it and come back. No, right? That's not going to cut it. If you do that on a whiteboard in an interview, you'll never get a follow-up interview. And but this way, the people will know that you are choosing the right data structures for the job, because no real program is ever manufactured with one data structure. Okay, in every real program that does anything solid, there's like hundreds of data structures people use, right? There's a list here, there's a tree there, there's a graph there, arrays everywhere. Okay, but they're all in the right places. And that is what we get to learn in computer science. And so I think this class was very nice. And thanks to you guys, really, because, as I saw, you guys were coding most of the time, right? I was out there just listening to you guys, and it was fantastic, right? And I'm pretty sure I'll actually watch this video too later on when I'm bored, right? After clicking through a whole bunch of Netflix movies and other videos, and say, all of this is boring shit. Let me just watch, Tim and Kate and Jaden. Much better. All right, so Thank you, and sticking around after class and all, right? I'm very, very pleased to and grateful that you respect the time that you are getting to learn these things. The only thing you should really respect is knowledge. I think people not worth not worth respect, but knowledge is the thing that we should respect. And then when you respect something, that will just come to you. Thanks very much. All right. I hope I'll see you all again on Tuesday. Please take this, post it in the forums, and see the discussion. Right. I think that many people are very busy with finals and work-related things. You got to be prodded. Okay. And you guys have to somehow reach out to these people either on Reddit or messaging and say, hey, there's this interesting problem. Let's go and tackle it. Right. Or share some thoughts and so on. You got to somehow get some discussion going around this and do that. And maybe Jaden, when you posted the code, get rid of the code that we solved at the end, and just leave the challenge comment in there and say, we solved this in class, right? So here's an exercise for you guys to solve. If you have any issues solving it, ask, and we will help you. And you guys can say, well, this is how we did it in class. Is that okay?
Yeah, I can copy and paste into GitHub and then just remove the answer code.
Yeah, just remove the answer code, right? But leave the comment there so that people can do it, and invite people to do it, right? Ask them to come and do it. Nobody's getting these extra points that I throw out. And so I think it'll be exciting for everybody. Yeah.
And if I did show any personal information when I share my screen, you can just edit, so you can just show a black screen, but leave the audio, and you can leave the audio.
Yeah. The only request I have is that if you can look at the video, right? And tell me that it's at 25 minutes 30 seconds, a lot easier for me. Is that okay?
Yeah. Thank you, Professor.
Thanks. All right, bye.
Goodbye.
How do I close the in Zoom here on the iPad? Oh, maybe just like this.